So we will start the session. Is my voice audible to you? Uh, okay. So welcome to the task two. Uh, First, I will share you the little bit info of what task two will be. Uh, if you completed your 1B, 1A, and 1C, then you uh, update your GitHub repo with checkout tags 1.2.0. So let's move ahead with the manipulation. After the checkout, make sure you replace all your necessary Gazebo plugins to the your binary folder. Here is the command for that to do. So let's start with the instruction. In task 2A, you need to first take the Aruko box TF, which you did in the task 1B. With the help of TF, you will move your arm to the box to pick up, and after the pickup, you will drop that box on the eBot. So that's the main uh, uh, that's the main actually the point of the task 2A. And the most further thing is while the placing the boxes on the eBot, it will be the pipe up. So to remove the boxes, you can use our server link service. You just need to call the server links service as same as what you call in the attach link, and as well as detach link also. Here is the sample snippet of it. How you can do it. Make sure that while you are launching a Gazebo file, Gazebo Python script, that these two lines are visible. If these are visible, then you are good to go. So how to start it? First start the Gazebo Python script, and then start with the RVs. With that said, that you are you can manipulate UEFI and all the things. So as you can see, here is your expected output. How to do it? So the main important thing of this task is you need to do all the thing in one go with the serving manner only. So what that serving manner means, you cannot use existing UR5 move it planner libraries. And in for submission method, you need to add this Python script as well as your backfill and environment, and same as submit your video also in your portal. So little bit on hint on how to do in surveying, I can you can actually see in the learning section. of Move It Servo, where you can actually get an idea of how to do it, how to do servo, or what is serving also. So what basically serving is that you just give the positions to the arm, so precise position. So the arm will move the based on how the you set the linear and angular velocity of it. So make sure that there are also two types of serving uh, message publisher. One is which is time spent, and another is a delta joints commands. So the main difference is that freeze stamp will act as the velocity and angular force, which will act on UR5 end factor, while delta joint commands will move the UR5 with uh, how much degree you want in specific joints rotation. So that's the main thing. You can also see the here in the video as well. Or yeah, or you can even see the what the surveying is in the YouTube, or you need to also learn the inverse kinematics and forward kinematics to do before it. So that's it for the 2A. Like, do you have any questions regarding to it right now?
So what were the two type kinematics that you learned us to learn as a prerequisite?
One is forward kinematics and another one is inverse kinematics. So you are what the difference is that the inverse kinematics you will calculate all the joints angles with respect to the like where you want to move. So for example, like you are did in the 1C. 1C there are two Python files. Wait a second.
Yeah, join.
Yeah. There are two Python files. One is the move to pose, and another is the move with the joint states. In the move to pose, the first you just give the XYZ where the arm should move to the. Then it will calculate all the joint angle required for that. That is known as the inverse kinematics. While the forward kinematics is that you just give the joint angle of all the UR5 respective joints, and it will plan to it. There are also many videos regarding to it.
They are discussing only talks. Acha, 1C they are discussed. No, they were currently opening that UR5 control.
What? Does anyone others have questions regarding 2A?
Oh, sure. So for the Python file, where should we place it for the task 2A?
What actually?
So I'm unable to place the Python file at task 2A. So what should I place in the right right
Which packet file, like
Python script of 2A?
can you chat in the box? Like I am not able to hear you.
Okay, sir.
Sir, is move to post goal also considered servoing?
No, like what does move like basically move to goal also do the what serving does. So but what move to post do is that it plans the your inverse kinematic and forward kinematics and then send it to the serving method. So like what you have to do is you need to calculate your own forward kinematics and inverse kinematic.
Hello.
Sir,
Hello.
hello.
Yeah, sir.
Sir, actually,
Hello. Yes.
So,
actually,
can we use the move to config method while providing the all the joint angles?
No. Like
So we have to
both.
only move. give the twist temp commands.
Yeah, you can use only twist and commands and delta join commands only.
Okay.
Sir, in my Aruko frames, when I submitted in the two-way auto eval script, it said that zero Aruko angle correctly detected. So can you explain what is meant by Aruko angle with respect to the base link or camera frame and how it should look like?
Okay, so basically what the Aruko angle should look like with respect to UR5 is like this. So just it that the UR5 sees the Aruko box in the with respect to like this. So check that whether your like perfectly are in place.
Sir, keeping the roll and pitch as zero, it was not happening. Like we need to then give some
Yeah,
values, roll and pitch.
you need to adjust it with the how the box is rotated also.
Yes, 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 yes,
Yeah,
yes.
for that you can calculate with the help of the R vec using rotational vector where you get from the like while you're detecting the Aruko box, you
Yes, yes.
actually get the rotation vector. With that help, you can actually get the how much the Aruko is tilted, and later on while publishing, you can add that offset to it.
Okay, I see, I see. My frames are not yet properly aligning. I will try to like I was using RVEC only, but still it was not aligning. Again, I will try.
Sir, this RVC is coming from the camera thing, right?
Yeah, yeah.
So it is somewhat like distorted or rotated in some axis. So
Uh,
we should
let's
manually rotate it in the opposite direction while publishing.
yeah, you need to actually while publishing, you need to actually rotate like how the Aruko box is. So it's like nothing. You just needs to add the offset what you get from the RFAC only.
Yeah. Now this offset should be added to the RVEC directly, which we got from detect RVEC function which we have.
In starting, yeah,
One.
it's like in starting you are getting the direct rotated like Aruko box angle.
Yes, RVEX.
Yeah, but if
For that, we have to add some offset and publish to
yeah,
camera topic. Cam one only, sorry, cam one frame with respect to camera length.
yeah, right.
And then we have to see this frame with respect to base and publish once again.
Yeah,
And so in this in between, if we want to differentiate between rack and down or something on the table box, if it is the rack or table, so we have to give a manual condition for that, or will it be
manual condition for what actually?
if we want to detect if the box is down and
Yeah,
rack.
yeah. For that you need to give the manual condition only.
So,
Yes.
so sometimes when I launch my Python script that we have to make, so some the rover ebot Aruko marker is not detected. Like when I try run once my script, it is the Aruko
Okay.
marker 12 is detected, and when I rerun that script without reopening the RViz and the gazebo, the Aruko marker 12 is not detected.
Uh, and that the simplest solution for that problem is you try to use in try catch method only. Like it's not like sometime it will doesn't come the your TF, so it needs time to actually the load. So
So,
try using try and catch method. It will solve your problem.
so I'm using try and accept method, but the the time when it didn't detect the Aruko 12 marker, it is giving me error. So should I increase the like
No, no.
running time
No,
or
no, no. What you need to do is the in the try and catch method, you will first try to catch the what you need to listen the Argo ID,
Mhm.
and if there is an error, then you just need to like ignore that and try again. Just you
like
need to
ask
try
the loop
again
to
and
start
again
again?
until it doesn't come.
Okay.
Sir, actually the error is in RGB image because in RGB image it's not detecting that. That's why it's not publishing the TFs.
No, no.
I also
Yeah, the main problem is that the when you launch your script,
prediction.
that it doesn't guarantee you to get the image as you like wanted. Like I start the Python script now, it will not give me the directly. So it will just wait for 1 2 seconds, then it will give the images.
So the time which it will take to identify the markers, will that time be counted in the back file?
Yeah, yeah.
Um, I mean, say it will be different. It will be different for each person who submit the files because the time it depends to detect will differ on the person to person or the system to system or
Uh,
script to script.
yeah, that will be different, but we only consider the sim time of your script only, like so there
Okay.
won't be problem as.
Okay, sir.
Okay, so we'll now for a moment move away to the task 2B discussion. So yeah, so just like Gaurav said before, you need to pull and build the repo. Then for task 2B, it basically you have to dock and place the payload. So the idea here is you need to, so if you see a section here near the conveyor belt, so you need to navigate into this slot, a C-like section, and drop your payload accurately on the conveyor belt. So to do that, you will be needing to firstly tweak your nav2 command script that you have used during task 1, task 1A, and then also write a second script called a docking script. So we have provided some learning resources. So what we will do here is, as you can see from the top here, you won't be able to navigate inside this C only using the nav2 package. So you need to do this navigation part on your own. To do that, we have provided with you a bunch of guidelines and a boilerplate program, and also some conceptual drawings here. So the idea is using the other feedback sensors that we discussed in the earlier sessions, that is ultrasonic sensors, maybe your encoders, basic or odometry. You can decide whatever way you want to navigate this robot accurately inside this. So how to when to start your docking script, when to call your docking script is entirely up to you, and that is a part of the task. So you need to figure that out on your own. Here is a sample video how to call the script from CLI, and similarly we have also given a command showing how you can interface it in a Python script. Going ahead, there is a payload service. So you need to so what you need to do is, if you go to the instructions here, as shown in the video, you need to navigate in front of the arm and then request for the payload. If you navigate accurately to the exact position, then the payload will be dropped on the robot itself. If you do not navigate accurately, then the robot won't be able to receive the payload properly. So this is the part of the task. So here you go, you call the payload service, and then you receive a payload. Now you take this payload to the conveyor belt, call your docking script, and then basically drop the payload accurately on the conveyor belt. And you do this thing again. Now, how to use the payload script? To understand how to use a payload script, you need to navigate to this page. Here we have given the necessary dependencies and how to launch the script and what is the structure. So the payload script takes in two arguments. One is receive and drop. So whether you want to receive or drop, you need to mention. So if you want to receive the payload, that is you want to spawn the payload like you've seen in the video, then you need to set this flag true. If you want to receive the drop the payload, then you need to set this flag true. And it will share with you a message. This message will contain information about which box that you have received and things like that. And using this message, your robot can make intelligent decision and accurately drop the payload. How we are doing that is you can see in the sample video here as well. So for this task, you have to create basically two scripts. One is the docking script, and another is similar to your ebot nav2 script. So using nav2, you will first navigate to these different poses, then go to the drop pose, request for a payload, go to the conveyor, drop the payload, come back to the drop pose, receive the payload again, and drop to the second conveyor, that is conveyor 1 here. So that is the entire of the task, and you will be making two scripts, and you can take reference of the ebot docking boilerplate code that we have provided in the GitHub. You will find that inside your well, in some directory. Let's search for it.
Finally, for submission, you might be familiar with this entire structure of eYantra auto eval by now, and you need to mention all the files, and you need to show your video something like this. So the two terminal windows where you launch your scripts, that is the docking script and the nav to script, should be visible in the terminal window. Your RV's map that you have created should be on the right side, and your gazebo world should be the largest screen visible. Yeah, also one more thing, you will need to recreate the map again. Since the world is different than the world that you used during task 1, you need to create a new map, and using this new map, you need to navigate now. So yeah, that's about it for task 2B. If you have any questions regarding it, go ahead. You can ask those questions right now. Yeah, any questions regarding 2A and 2B, you can ask right away.
Yeah, uh, actually, while I'm doing this, this ultrasonic sensor readings, actually it should be zero, minimum point 0.3 to 4 point something.
Okay.
But I was not able to read the ultrasonic signals greater than 1.15 to 1.16. I don't know, even if the distance is greater than 1.15, it is just showing 1.15.
Okay, I'm not exactly getting your question. Like, at what position you want you are taking the reading and things like that? Are near the conveyor you are talking about, or
No, if any wall is there, let's say any wall is there,
okay?
and when I'm going from the wall away from it, okay, perpendicularly,
Yeah.
the readings are increasing for a while up to 1.15, and then later on, even if I move forward, the readings are not increasing; it is still 1.15.
Yeah, that is basically the limit of the sensor.
Okay, that is the case for everyone, right?
Yeah, sure.
Okay.
That won't affect your performance anyhow, because
Yeah.
you want to.
Yes. Actually, in that it was showing if that 4.9 is like maximum it can get.
Mhm.
Maximum.
That is it is we have tried to mimic it hardware wise, but I try to recreate the issue that you are pointing out. If it is there, it will be rectified, but rest assured, it doesn't affect your task at all.
I was just confirming that if it is case of R only our workspace.
Okay, sure. I'll check it once on my system as well.
Yeah.
If there is a issue, we'll rectify it. But even if nothing comes out, like it won't affect the task to be
Okay.
other people. Yeah. Yeah.
So can we use that the coordinates of the conveyor belt, like some offset from the conveyor belt to navigate the bot to that conveyor belt respectively,
See
like
the
we did in task one?
so in order to receive the proper navigation point for navigating to the conveyor, you need to go to the points that we have mentioned in the instructions here. So conveyor pose, you need to navigate to this pose. After navigating to this pose, you can your docking script can take over and go anyhow into the C section. That's entirely up to you.
No, so I want to like you have given only the XYZ coordinate, not the orientation um, like XYZ
Okay,
orient.
so yeah, sorry, I think this is a typing mistake. So not a typing mistake, but the last point is basically the angular orientation.
Okay, sir.
Yeah, I will correct that. Yeah. Any other questions?
Excuse me, sir.
Yeah.
Sir, sorry to disturb you, but we are already still stuck in the task one. Actually, when we are saving the map and serializing it, so it says like 4 files should be downloaded, but we have only like 2 files. Like we are only getting 2 files, like dot data and dot postgraph only. The main file that is dot YAML we are not getting, and we have done it from scratch like 2 to 3 times, but still like that we can't move without that.
Hmm. Okay, sure. I'll what we'll do is we'll set up a meeting with you probably to take a look at the error, and we'll figure it out. Sure.
Okay, how the meeting details will be shared to us?
We'll contact you via discuss on personal message. Just ping on the discuss again. We'll message you.
Okay, thank
Yeah.
you, sir.
Sir, we are having some issue with the schedule of the task 2.
Okay.
So our college practicals and submissions were till 23rd of October, and main university practicals are going to start from 7th of November. So we are
Okay.
hardly getting 10 days to complete the task.
You can.
Can
Yeah, sure.
so can the schedule be postponed at the last date?
See, the thing is, each college and each university will have a different timeline. So, most of the students that are participating are facing similar issues. Still, if you feel like you are getting less time, you can always request extension to the help desk. But other than that, I don't think the timeline would change because it is too variable. For XYZ college, the timeline is something similar to you. For some other college, it might be different. So we can't
So
accommodate these changes for each college, right?
the main issue was like the Diwali is also here, so more time is less to us.
Yeah, sure. See, it's not in our hands to be honest. You can see the timeline will remain the same for everyone. But if you still want to just send a request, you can send a request to the help desk, and they will consider your request basically.
Okay, so okay, thank you.
Yeah,
Sir,
hi.
no?
Yes.
I have doubt
I
about
wanted
the
to ask a question.
pattern matrix in task 1A, 2A.
Okay, who's speaking? Can I speak again?
Hello, sir. It's Anis.
Kawale.
I have a question regarding the service.
Yeah.
Hello.
I have doubt about task
Okay,
2A. Hello.
just hold on a minute. We'll first go with Anis, then Raj, you can ask question. Yeah, Anis.
Regarding the payload service, do we have to call that in the command line interface, or do we have to call it in like the service
You
script
need to call it
that
from
we
your
have
script.
from the
You need
script,
to
right?
call,
Like if
yeah,
I'm
from
creating,
from Python script.
as in like the
Sorry, your voice break off.
sir, is it like do we have to call it from the docking script or the script where we are actually navigating the robot in?
I think you will need to call it in the navigating the robot script because you need to also request the payload using the same service.
Okay, that makes
But
sense.
it is
So
up
like,
to
and
you.
also, okay.
Yeah.
So wondering like, where do we start the service from? Like, is again that would be from the script itself, or would that be from the command line interface?
See, the service you can start via command line interface. The service call that you make, that needs to be from the script.
Okay, perfect, sir. That was the only question I had. I was thinking that we have to start the service from like another script and
No,
then
no, the
like
service
call
you
it
can
from
start
there.
via CLI. You can use the command line interface to start the service using the command that we shared in the learning resources. But the service call, you need to make it via your Python script.
Got it, sir. Got it, sir. Thank you so much.
Okay, yes. Raj.
Hello.
Yes, hi.
The in task 2A, the rotation matrix is somewhat, matlab, the actually as per your instruction, the z-axis must be going inside the box. It's correct, but the x and y-axis is somewhat tilted. Oh,
Like tilted in what like axis is like it's how much is tilted like
it's little bit tilted, but
okay, one thing like it's tilted
affect our,
with respect to camera. Hello,
yes,
like
no,
hello. Hello, hello. Uh, Hello. I think that Raj, that you are actually you might be using like you are not listing the right TF with respect to like it will never happen like in the ROS like it will never happen. Just make sure that you are listening to the right Argo ID and publish it again. So what you are actually seeing the tilting is might be the your logical problem only.
Okay, sure. So the GitHub repo of eYRC which background is not updated. Okay, what do you mean by that? Like, if you follow the instructions given correctly, then you should be able to get the repo. But after that, still you need to, after you clone the repo, you need to build it again. And still, if the changes don't reflect, then just do a clean build. And by clean build, we mean delete the build and install folder and run the colcon build command again. Okay, so that was a question from Sania. Okay. Okay. Okay, any other questions?
Excuse me, sir.
Yeah. Yes, go
Sir,
ahead.
I had a doubt relating to the rules of the competition.
Okay.
Sir, actually, my team was a bit late in submitting the task one because of our internship opportunities going on and some research work as well. Sir, so we were just really concerned that would we be allowed to enter task three, given that we have a bit of we have some penalties in task one.
Okay, yeah. So as long as you are above the threshold, if you score good, even with penalties, there is a chance that you will be able to qualify. So it's not like just because you
Sir,
have
what are the
submitted late, you will be
thresholds?
disqualified. As long as you get good score, you should be able to clear the cutoff.
Okay, sir. Sir, so our main aim is not to be in the top list from the competitors yet, but just to pass the threshold with a good score.
Yeah, that is one way of looking at it, but you can also aim for the leaders board. That
Yes, sir, that is always, but right now, given the situation, we really need to get into task three as well with a good score.
yes. So if you just perform your current task nicely, then there is a chance that you might qualify. It's not very unlikely or difficult to achieve.
Okay, sir.
Yeah.
Thank you, sir.
Yeah, no issues. Hi, good evening. I have query about leader. Even after that, I have noticed my rank got increased 70. To ask if there is no penalty on submitting task. Okay, so the Mirang's question. So your some people might have submitted the task, and even with penalty, they might have better marks than you or better things than you. That's why your rank got shifted. Then, do we have to start the payload, sir? Okay, yeah, Anis, that we answered. Yes. Anyone else?
Sir, will you be contacting us now in this meeting itself, or you will be sending some other link or something else?
No, no, send us a message. Not today, but we'll most probably I'll talk with my seniors and then we'll finalize how we can resolve this issue.
Okay, so like you are noting my email ID or something, so you can contact me,
You
or
can
like
just to send a personal message on Discuss itself.
discussion forum.
Okay, just the topic that we are having discussing your issue on in the Discuss forum. Just message on that topic. I'll reach out to you.
Okay, sir. Thank you very much.
Sir, for task 2A, we need to basically write. I know and the code, so ARM can plan to TH.
Yeah, sis, you actually need to actually the learn what the inverse kinematic and forward kinematics are to do for the task 2A. Like you didn't need to learn all the conceptual thing of I gave inverse kinematics and forward kinematics. You just need to know the top of it, little bit of it, so you can actually do it.
Hello.
Hello.
So I had one more doubt regarding task 2B. So far, like I've been able to navigate the robot properly, But what the issue is that, like, from the start point to the first waypoint where the box is being dropped on the robot, like that goes out correctly, like the robot aligns correctly. But when the robot goes to the conveyor belt and the all the dropping and the docking, the box is being loaded on the conveyor belt, and after that, when it comes back again to the dropping point, there is like somewhat of an offset from the point where the conveyor belt is to the point where the box is supposed to be dropped, even though like I'm using the same coordinates for the drop point. So
Yeah,
is it
so
okay?
for that you need to take a look at how global and local planner works. So understanding how these parameters work will help you achieve better results.
Global and local parameter
Yeah.
in the params, right?
Yeah,
Nav
yeah. You need
params.
to tune your parameters basically.
Okay, like no need to provide another waypoint, right? From the conveyor belt to the
No,
drop point.
that is the bad way of doing it. So that is something that will lead to more offsets, more errors, and it is basically a jugaad.
Acha,
Like,
make
yeah.
okay, got it, sir. Thank you.
So Jaden is asking, do we need to make a service client from eBot docking service and call it from that? Yeah, so you need to create a docking service. You can take the eBot docking boilerplate as a reference, and you will create your own docking service, and that docking service you need to start. And that service call you will make from your command script, nav to command script. Yeah. Any more questions?
Hello, sir. When I had doubt regarding the topic list. When I launched Gazebo file, and then simultaneously in other terminal I did a roster topic list, and the topics are not visible. Some of the topics, even though the packages are installed.
Okay, so the Gazebo world is launching properly, right?
Yeah, Gazebo is launching, but the ultrasonic packages and the local cost map, they are not
Yeah, so
visible.
have you sourced your workspace so even if you open a new terminal window, you need to be inside the workspace or basically source the workspace in order to see the topics.
Yeah, I did that. Like after facing this error, I deleted the repository, deleted the directory and cloned the repository like from starting. But still, it's not
Yeah,
displaying.
so it's that is one good step. After that, also, if once you launch the Gazebo, you open a second terminal. There also you need to run the source install setup.bash.
But it's like bash RC mein kiya hai.
You have installed, you have put it in the bash RC. Then it should not be
Yes.
an issue. Just share more details on the Discuss forum itself. So that way we have more information to help you.
Okay, thank you.
Yeah.
For
Yes.
So you said that I need to look into the global and the local cost map parameters for this.
You need to basically tune your parameters. That's it.
Pardon, sir? I'm sorry you broke off, sir. Hello.
Himanshi, Himanshi, yeah.
Sir,
Adding that
voice broke
inverse
off,
connect
sir.
code. Hello.
Hello, sir, it's Anis here. Your voice broke off. Like I was asking about the local and the global cost map parameters. The doubt
Yeah.
that I had.
Yeah, sure. Go ahead.
You said, sir, I was wondering that like in those particular parameters, like could you like point me like where like which parameters should I focus on
No, that is
to
part
make?
of the task. You need to explore it on your own.
Okay. You had mentioned something like earlier, but your voice had broken off, sir.
No,
I'm
I
really
just
sorry
said
about
that
that.
you need to tune your parameters.
Yeah, you just said that to tune the parameters, right?
Yeah.
Like, okay, and it's like the local and the cost global parameters. Like my issue was about the waypoints. So like while coming back from the conveyor belt to the drop point,
Yes.
like there is like some sort of an offset. Like
Yeah,
it's not
I
coming back to.
know. I know that is due to your parameters not being tuned properly.
Okay. All right, so I'll take a look
Yeah.
into it.
Oh, okay, Himanjoshi, you are saying is that instead of inverse calamity code, we can like the what you do in the PID control is actually the same as it is what the inverse calamity is. Like both are actually somehow similar only. Like you can choose any of the method like you actually get to it, but both are somewhat similar. For task to be
Yeah, so Ashish, that is due to your script. You need to basically that is the issue from your script, and you need to check logically, a good point would be maybe starting your robot slowly, but it is a script in your issue and it's a logical issue, so you will figure it out. Yeah, any more questions?
uh, Gunendra Singh, like there are many sources for the delta join command, but instead of like finding the sources, you can actually like directly try out what the delta join command is while publishing the topic in the command line only. You can also use the ROS2 like GUI, which is a ROS2 GUI, like where you can actually see all the topics and even actually publish each one of it. It's very helpful, like see to it, like.
Okay, one critical point task was regarding saving and serializing the map. We have been stuck here, provided any question for him. Yeah, we addressed the issue before, so we'll be just ping on the discuss again. We'll discuss how we can help regarding that. Just okay. So, any other questions? Okay, so we'll end the session now if there are no more questions. If you have more doubts, you can. Yeah, sure. Go ahead.
In
Like,
script file.
can I say something?
Yeah, go
Yes.
go ahead.
So like very much thank you for like conducting this session and all. Plus like as I said earlier, like we are still stuck on this task one. So like we need it like very very urgently, and if possible to have like that those 2 files or those 4 files in the forum or something. So we will directly go ahead with that, saving and copying into the folder required. So it can like if it can be happen, so it will be like very very good for us, and we will appreciate it.
Okay, sure. We'll see what we can do.
Okay, okay. Thank you very much, sir.
Yeah.
Have a good night.
Uh,
Yes.
in
Yeah.
one we were firstly taking the RX from the detected RPS, right? And then,
Sorry, my voice is breaking. Can you repeat?
in one B script file, we were taking RX from the detected RPO, right?
RVs from the detected Aruko.
Sorry, actually, can you repeat the question?
We took the RX which were detected from the detect RPO function, right?
Yeah.
In one B script file.
Yeah,
So
yeah.
while in that boilerplate, it was it's noted that R should be 0 and P should be 0, and yaw should be changed somewhere
Yeah, yeah.
with the error function. Even after that, the TF which you are the published TF which you are getting from R which are somewhat tilted or something.
Yes.
So we have to manually offset it, right? Even after that, like even after changing your value, corrected your value.
Yeah, yeah. You need to actually manually add the offset to it.
Okay, for any required one, and then
Yeah.
publish. Then the TF problem will be mostly solved, right?
Uh, yes. Like. Okay. Uh, Okay, Parth Gupta, you need to actually write your own forward and inverse converting. Like you will write your inverse converting only. Like forward converting is not. I think both are possible that, but I think you will write I. But yeah, you need to create your own. Okay, hello sir. I heard doubt.
Yes, okay, sir. Thank you.
Doubt and hello Rudra. Actually, what is meant by that? You got a problem detecting all the survey of the given object. Like it's moving like it's going to in like inward towards the box like hello Rudra. Uh, is your like gazebo world perfect? Like uh, uh, actually I'm not able to get it. Like you can share the photos regarding to it in the discuss forum. Like okay.
Yeah, so if there are no more questions, we'll end the session now. So we'll share the recording shortly. If you have any more questions, you can reach out on Discuss Forum. Yeah, all the best. You can leave the meeting now. Okay, wait. Sir, you say, as you said, we have to create a service in eBot docking service. Why? But aren't we using the dock as our service message? So let me just enter. Yes, you are right. So we have already given you the message format. You just need to write the logic for the service that implements the message format. Yeah. So yeah, all the best everyone. We'll close the session now. Thanks.